in Kotlin, functions can also contain other functions. So let's take a look at the way that works. And to do this, I'm actually going to do a more real-life example than the examples we're typically seen, in the sense that I'm going to write a solution to a quadratic equation. So I'm going to have a function called solve quadratic equation. And it's going to take 3 arguments, all of them of type double. So it's going to be A, B, and C. And it's going to return a pair of double values. Now, pair is another Kotlin type, very useful for returning a pair of something. That should be a double. So we're taking in 3 values, A, B, and C, and we're returning a pair of double values. So to solve the quadratic equation, you need to calculate the discriminant. And to calculate the discriminant, we can define a function which is defined right inside this function. So the way we can do it is we can say fun, calculate discriminant, taking A, B, and C, and then what we can do is we can return B times B minus 4 times A times C. So that gets you the discriminant. And then, of course, let's not forget the return type. Then, of course, you can just calculate the square root of the discriminant. So I can say, for example, val root of the discriminant being equal to math.sqrt of this function call. So I can calculate discriminant with A, B, and C, which are taken from the arguments here, and then I can return my actual value. So I can return a pair of values where we have minus B plus the root of the discriminant divided by 2A, and then we can just duplicate this and have the minus here, minus, and that would be our 2 values. So here we have a function within a function, and obviously this inner function isn't really accessible to anybody outside, in the sense that here I cannot call calculate discriminant. You can see that it's not part of code completion. So let me comment this out, and we'll try this function out. We'll actually get to see how it works. So it's fairly simple stuff, really. So what I can say is I can say val x1, x2 equals solve quadratic equation 1, 10, and let's have 16. And then I can print out those values. x1 equals $x1 and x2 equals $x2, like so. Let's put x1. Oh, we don't need to. Sorry, forgot that we are in a very progressive language. So what's happening here? Solve quadratic equation returns a pair of values, and this assignment with round brackets is destructuring. Destructuring is a way of assigning something and breaking it apart into its constituent parts. So here we took a pair of values and we destructured them into x1 and x2, and if we run this, well, hopefully we'll get our correct result. Alright, so the roots are -2 and -8, and you can verify that this is in fact correct. Now, the final thing I wanted to mention, which is also really cool, is that the inner function can actually capture things. It can grab things from the environment and grab things from the arguments of the outer function. So really, we didn't have to pass those values A, B, and C, and here we can actually comment this whole thing out. Not the line though, just the arguments. Let's actually get rid of them. So the idea is that you can get rid of the arguments here, and you can get rid of the arguments here. And what happens then is these values of B and A and C are actually taken from the outer function. They're taken from the actual arguments. And obviously the behavior of the function and its use is exactly the same. The only difference is we sort of cut down on the noise. So that's the other thing I wanted to mention with regards to functions within functions.